In this video, we will solve an example using the one-sample t-test. Recall that we use the t-test in situations where we only have sample data and do not know the population standard deviation. The t-test is the bell-shaped curve similar to the normal distribution, but it has a bit more area in the tails to make up for the fact that there may be unknown values when we're only working with a sample standard deviation, so we like to leave a little bit more room for uncertainty. So let's look at this example. Students in an LMC statistics class conducted a research survey to find if people carried more than 50 cents, or $.050 in decimal form, in their pockets. So I've highlighted this sentence because it includes our research inquiry question, and it also tells us that we are comparing to 50 cents. That's going to help us write our alternative and null hypotheses. The students surveyed 125 people in as close to a random sample as possible. So since they did their best to do a random sample, we're going to treat our sample as if it is truly random. The data is in the StatCrunch file named Statistics Survey Pocket Change, and we are going to test the student's claim and explain your conclusion. So this is quantitative data, so we are predicting about a population mean in our hypothesis test. So in this case, mu is the mean pocket change for the whole population. And you could say, this is the population of all people in Contra Costa County, all people in California, all people in the US. You could be real specific about who your population is. Our null hypothesis is going to say that the mean equals 50 cents. We'll use decimal form, so we'll say 0.50. And our alternative hypothesis will say that the mean is more than or greater than 50 cents. So now we want to head into StatCrunch and find this data file, Statistics Survey Pocket Change, and collect the summary statistics. So I'm going to go into StatCrunch. I'm going to go to Datasets and search for Pocket Change. And that should bring up the file for us. Here it is, Statistics Survey Pocket Change. And in this file, we have just one column of data, and it has 125 entries, all with different amounts of pocket change that people in the survey had. So we are going to go to Stat, Summary, Stats, Columns, select our pocket change column, and then you can leave all the statistics highlighted and get the full output, or if you just want specific, you can go to Stat, Summary, Stats, Columns, and then say you just want the mean, and you hold down Control and get n mean, and then we want the standard deviation. And then we can see if we want the standard error. The standard error just takes the standard deviation and divides by the square root of 125, just like we do in our formula. So either way, whether we get all the statistics, we get all those values, or if we just want to click on the summary statistics that we like, we can get those as well. So I recorded here, and the sample size is 125, the sample mean, the 0.49472, and the sample standard deviation. So for a sample standard deviation, we use S instead of sigma, and that denotes that it's a standard deviation from a sample. Similarly, for the sample mean, we use X with the bar on top. So now we want to find the t-test, t-stat, or t-scores we call it, and then we'll use StatCrunch to find the corresponding p-value. And we'll see StatCrunch does the same t-calculation for us, so it's not necessary to write it out every time. So the t-stat looks a lot like the z-stat. The difference is that instead of using sigma, the population standard deviation, we use S, the sample standard deviation, to find that standard error down in the denominator. So on the numerator, we are calculating the sample mean, 0.49472 minus 0.50, and we get negative 0.00528 because that's a bit below 50 cents on average. So that's not good evidence that there's more than 50 cents, right, if our sample data was actually less than 50 cents. And then the standard error, this is called the estimated standard error because we're using sample data. We take that sample standard deviation and divide by the square root of 125, and we get the 0.02509. And so when we divide, we get negative 0.2105. So if we head back over to StatCrunch, we see our standard error here that StatCrunch gave us in the last column here in my summary statistics is an exact match for what we get by hand. So you know me, I like to rely on technology to do my calculations. So I normally wouldn't go through calculating this by hand because I'd make a mistake. I'd make sure I entered my data correctly and outsource it to StatCrunch. If you think you've made a mistake, you can check it by hand, but for the most part, we can rely on StatCrunch to calculate more accurately than we do by ourselves. So now to find the p-value and verify our t-score calculation, or t-stat, you can call it either the t-score or the t-stat, we are going to head into stat and then see right below z-stats where we've got the t-stats. This is one sample, and then it's going to be with data because we've got all of our data here in the column. You could also go to with summary and enter the summary data that we just found, either way. So we are going to go to pocket change, and then in our hypothesis test, we're comparing to 50 cents. And then our mean, we are testing to see if it's greater than 50 cents. And then we want to see the p-value plot as well. So I like to click for the optional graph and table. Go ahead and hit compute. And here are our results. So you can see the t-stat is an exact match for what we calculated by hand. Since there are 125 data values, the degrees of freedom, df, is one less than that, 124. And then our p-value is pretty big, 0.5832. If you go look at the t-distribution graph, you see that's because our results were a little bit less than 50 cents. So our results are actually over here on the left side of the graph. And because we were testing for more than 50 cents, we're measuring the area on the right side of that. So we definitely have a pretty large p-value here. So it seems like it could be true that the mean is 50 cents. There's not evidence at all that the mean is more than 50 cents because our results were under 50 cents. All right, so we record the p-value and then we use that to make our decision and write a conclusion. So here's one way you could write the conclusion. The p-value is a large p-value above the significance level alpha equals 0.05. By default, we use this 0.05 significance level, and we weren't given any other significance level to use. So this is our default. We failed to reject the null hypothesis. It could be that the mean pocket change is equal to 50 cents. If the mean pocket change was 50 cents, we would not be surprised to see results like this data where the sample mean was right around 49 cents.